So I picked up a little something at the hardware store. Seeing as how this channel is electrically themed, I thought it only fitting to get a nice solid electrical box to protect my delicate circuit breakers. See? And to keep out trespassers. But I must say, the thing does have a mind of its own. Happy Halloween. So this thing is charming and all, and I love it. Only $20 too. Battery powered, nice big and solid. It's got motors, it's got wires, it's got everything. It even supposedly responds to audio, as in if you make a loud noise it'll start up on its own to be extra spooky. Although I haven't actually gotten that part to work. But there is one problem you may have noticed. It's very loud. It would be loud enough with the cables wiggling and all that, but the audio playing of the electricity arcing through the air sounds is monstrously loud. And I get that it's not supposed to be right next to you. It's supposed to be spooky on a wall or something like that. But still, a small modification. I want to go in here, and not a teardown. I want to keep this working. But I'm going to go in here and I'm going to disconnect and hopefully remove and use the speaker in something else, as well as the microphone if one exists, because like I said, it doesn't seem to respond to audio, though the manual says it should. So let's begin a quick examination. So a brief rundown of its operation. It has a switch with 3 operating modes. Off is off. On allows it to be operated according to the manual by audio, by a sharp audio causing it to turn on, but I can't get that to work. But more importantly, with the actual on and off breaker switch, which I will now demonstrate. And the mode that I had it in before is called Demo. It's meant to be used in the store. There's a little button here that was connected to its little cardboard backing that would say Try Me on it. So you could press the Try Me button without removing this from the backing, and you can toggle it on and off, trying to get it to close nicely. So those are the 3 modes. Now, the demo switch actually looks like it has a plug that can come out, which it just did. So I think I'll go ahead and just take this and use that in a project. It looks like it'll plug into a standard header, 2-pin, so I might have just gotten a free push-button switch. Now, for safety, we will take out the batteries, and it is doubtless that there will be some sort of capacitor in here. Well, I suppose it's not a guarantee, but it is fairly likely. So on that assumption, until we see otherwise, we will assume that there is a capacitor somewhere in here and not touch it, except with a resistor to discharge it. So it runs on 3 AA batteries, and these are the super weak store batteries. You're supposed to put your own ones in there. But they were connected back and forth, so that means they were in series. So this uses 4.5 volts. That's unsurprising because it's running motors and it's running LEDs. So there we have the batteries. And since I do want to keep this in working order, I will put the battery cover back on so that it does not end up somewhere on the floor. So we can see a radial set of holes here. That's going to be the speaker. Makes sense for it to be there because the sound would be consistent rather than being modified by the flapping in the front. And also this would be against a wall, so the sound would spray basically everywhere, perhaps with a lot of echo. Now, there are 6 holes all around the edges, which is usually what you'd think of as screw holes. But if I use my handy-dandy flashlight and shine it down in there, there are no screws. They are just holes. In fact, on no side of this device can I find a single actual screw hole other than the battery cover. So obviously it must be through here that you access it, that you remove this cover. But there is a spring, and that's how it works, in fact, especially since it's supposed to be vertical against the wall. There is a spring that applies pressure to pull it in. And then there's a motor right in there that kind of kicks the top of it, and the spring keeps pulling it back in. So again, if I wanted to tear this down, I would just rip it open, but I want to keep that spring in working order. Opening the lid a little bit, I see there is a screw holding the spring down, but I can't get to it without destroying the spring by pulling too hard. So then think about how this must have been manufactured, probably by a machine. The other option is the hinges. If I could lift this off and tilt it slightly, then I would be able to access the spring without stretching it too much. So let's take the hinges out. Examining them, there is simply a metal pin that holds the 2 halves of the hinge together. So I will take a small screwdriver, a flathead, and use it as a pry tool. So I'll just go in here And I'm sorry you can't see it well, but trust me, I can't see it well either. I'm just going to take the flathead screwdriver and shove it in gently, try and apply some friction to try and get at the butt of this hinge right here. And I might need a smaller screwdriver. Nope, we got it. So just gently apply some pressure, get some friction on the metal, and now it has come out a bit. So now needle nose pliers, see I'm using actual tools. Grab the pin, pull it gently. When it's part way out, get a better grip. See, if you're pulling on the extreme end the whole time, it's likely to fly off. When you have it part way out, grab it by the middle. And it's less likely to get flung when you get done pushing it out. Do this other hinge the same way. Needle nose pliers to grab, pull it some, get a better grip, pull it some, get a better grip, and pull it out. And then we just have to remember, on the hinge, or the hinge pin, there is a little rough part, which I'm sure you can't see, right there on one end. That one, on both of these, was towards the outside. Let's try and remember that. So now the lid will just come off, and I have to be very careful and try to access this spring, which is easier said than done. But I think if I do it this way, it won't stretch too much, and indeed not. It's stretching it very little. Once I can get past this careful part, I'll give you a better angle, but I am now unscrewing the spring from the lid. So there was basically just a screw holding it on. I can now slide it down a plastic post. So here's the spring, and it's just got a loop of metal, and it was hooked onto a little plastic post, and that's all it was. There was a screw. In fact, I'll put the screw back on once again so I don't lose it. The screw just kept it from falling off. So there's our lid. Now we can see modern electronics and miniaturization. There's not actually a lot in here. But the first thing I see is the speaker, large and circular, right there, which matches up with the holes on the back. So the first bit of good news is I see exactly 2 wires, which means there's no complex circuitry inside the speaker. The circuitry is all on this circuit board here. This is essentially the motherboard, the control board, and it just has 2 wires coming off, and those will supply power to the speaker. So presumably, if we just disconnect those wires, then the circuit will continue to function normally, but the speaker will simply be unpowered. So the way it would work is the circuit board would set a voltage, and that voltage would cause current to flow through the speaker, which would cause the magnet to go one way or the other according to the sound waves. So it'll still, if I remove these wires, it should, remember, don't mess around with stuff you can't afford to screw up, but it should simply apply the voltage and nothing will take the voltage and it'll just continue on its merry way. Sort of the same way when I removed the rumble motors from my gamepad. It applied the voltage to cause the motors to turn, but it just wasn't there, so it didn't do anything. But the gamepad worked fine. So the wires are soldered on, and again, I'm touching things, but first I'm looking for capacitors, making sure I'm not touching capacitors. There are little strings of glue. That's gross. But anyway, so if we look, we have a handle here, and that handle, when it's pressed up in the on position, there is a little, I don't know, it's a piece of plastic that pushes a piece of metal. And when you push it up, it makes those 2 pieces of metal contact, and it's a switch. Now, I'm being very careful to not push too much, because remember, there's a slat on the front of here. This is something you have to keep in mind when you're working with electronics, or devices of any kind, even non-electronic, mechanical. There's a slot here, and that slot will limit the movement of this lever to the designer's specification. And they know that slot is there. It's not to be operated like this. So they don't have to worry about this being pushed too far and snapping something off, because the lid will prevent it. So you have to be careful. That's just one of those little pitfalls you might not think of. And I love how they have cable management in here with a piece of Scotch tape. A little bit of transparent sticky tape and glue. Apparently they glued it and then decided that wasn't enough. In any case, let's go ahead and disconnect this speaker. Now, it would be cleaner to desolder it, but there's really no point to do that. So I'm going to simply snip the 2 wires, since I am sure. And like I said, the worst that happens is this doesn't work anymore and I have a display piece. I'm not gambling with things I can't afford to lose. So I'm going to snip it close to the circuit board, basically just leave that little bit of wire, and there we are. So now the speaker has been disconnected from the circuit board, and there are just the 2 little bits of solder. I will now unscrew the speaker so that I can keep it and hopefully use it in some other project. It's not going to be a good speaker, but I'm also not trying to make something to be sold, which means I'm the only judge of quality here. So I take this off, and I see that the speaker was not actually held in by the screws. It was held in by the flanges. See, the screw It's just a regular screw, but it's got a big, almost like a built-in washer. It is. It's basically a built-in washer, like a big wide head. And that was simply over where the speaker is. The speaker, and that's going to be a little tricky here, the speaker is just kind of inset. I'm trying to get it out without damaging the diaphragm. I could pull on, if I pull on the, yeah, I'll pull on the wires because, there we go. Because I observe the wires are soldered on, which means if I rip them off, I can solder on new wires, so it was safe, and it came right out. It's even helpfully labeled positive and negative. How nice, speaker, how nice. And the diaphragm is just a piece of plastic, so there you go. So now, we have a speaker. So the other thing was a microphone. Now, a microphone, I don't know what it looks like. But let's analyze what happens. We have a motor that moves these things down here, which is obviously got to be this physically connected. And I see what looks like a motor there. There's probably some gearing that changes a spin to a back and forth. The wires are cosmetic only. Although actually, no, they are cosmetic. There we go. They were just sharing some of the colors. The actual wires in here were looking like the wires down here. That's funny. But anyway, these wires are cosmetic, so we can ignore them. And then the LEDs would actually be in here. And then we have the switch, so that's these two wires. Now the battery compartment, we would need 2 wires from the battery compartment. Now if I'm counting, there are only 2, 4, 6 wires unaccounted for, because all of these wires go down here. So that's for LEDs and motor and stuff. 2 for the switch. There are 2, a white and a red, that are very close together on the circuit board. And one of them is soldered to something that looks like it's coming through from the battery compartment. Right about there on one corner where one end of the battery would be. So battery, then up to battery, then down to battery. So now this corner would be the other end of the series batteries. And the white wire that's near it on the circuit board goes around and is tucked under this motherboard, which I could remove, but I don't need to. It's tucked under about where it should be. So I'm going to assume those 2 are for the battery compartment. Oh, there are labels. There are actually labels. So there we go. One end of the switch is connected to what says on off, and the other end is just down at a resistor. Oh, there are. Okay, speaker is labeled SPK, and then VDD, but this one is not labeled. This is just BZ minus and BZ plus. But that would seem to indicate a positive and negative connection to something, and it is a, of course hard to see, silver dome, thin dome circle of metal. In fact, suspiciously of a similar shape to this. Now, what's the difference between a speaker and a microphone? Very little, actually. The materials use the actual parameters, but in essence, in core, a speaker is something that, in response to voltage, moves air with its diaphragm in and out. And a microphone is something that air moves its diaphragm in and out and generates voltage based on that, because moving magnetic fields and so forth. We'll do videos on speakers and microphones later. But it's got 2 wires, plus and minus, that don't appear to go to anything else useful. It's supposed to have a microphone, and it looks like one. So, in the interest of let's just try and see, I'm going to disconnect that too. So the first thing is I'm going to try, actually let me disconnect the wires first, since I have committed to this. And one of the switch wires is right next to it, so we're going to be careful. So we'll do a snip there, and we'll do a very careful, very gentle, very delicate snip right about there. So now I will examine for damage, and the switch is being held on by a thread, but it already was. They did not use over much solder on this, but then again, why be wasteful? So now, unfortunately, the microphone is glued in rather than being screwed in. So it is time to employ a small amount of calculated violence. Now, if the only goal was to disconnect the microphone and speaker so they wouldn't work, you would just snip the wires and be done. No reason to even bother taking them out. But I would like to use them, because why throw away potentially good parts? There we are. The glue is not completely hard. It's actually a firm gum, so it is coming off, of which you can see none of this. I'm just digging at glue. And I hear cracking noises, which is worrying me, but I'm thinking that is just the glue coming off of the plastic. There would not be any exposed circuitry here. I can actually come in from behind. I'm coming in through the mounting hole to lever up some of this glue. You've got to get creative, and especially this is good because I can apply very small force, which means my screwdriver is less likely to go flying off into the ether or my eye. you should be wearing eye protection. Also, there's the capacitor, if you can see it. Right here, perhaps you can see it, right at the top sticking up. That's a big old one too. That is an electrolytic capacitor because it has a positive and negative. And I can't find where it has the capacitance rating, but it does say 105 degrees Celsius. So it is a big old beastie, which is unsurprising since this is intended for use outdoors. At least I think it is. There is no waterproofing, but I don't think water would really be a problem. Unless you're in a typhoon. If this is mounted vertically, it's unlikely to get in there at all. And it's also inexpensive. So yeah, I wouldn't really worry about it. Almost there. See, I don't want to just pull because I could be pulling on something else that I don't realize in my zealousness. And yes, if you wanted to be safe, you could go ahead and touch a resistor across the capacitor leads, but I'm just going to not touch it because I don't need to mess with the motherboard at all. Try some pliers. Careful modification is always more difficult than destruction. Perhaps that's why you have to pay a lot to get something repaired. There we are. Now the problem is the rest of the glue is also inside its little slot. So what I'm going to try to do, emphasis on try, the angle is not good here. The proper way to do this would be a heat gun, because you could apply much less heat than would be damaging to any component, and it would soften the glue. You don't need to melt the glue. You would just soften it a little bit. Ooh, okay, that accidentally worked. I was levering the microphone and ended up pushing it down, which broke the glue contact with its surface enough before I shattered the microphone. And yes, I am confident this is a microphone now. It has a hole there, which goes into its little diaphragm. So there is our microphone. Now, that was all the modification this needed. So let's put her back together. Now, it would be wise to go ahead and test. In fact, yes, let's be smart. I will put the batteries back in, and we'll go ahead and test it. Make sure the switch is off. This has been in demo mode the whole time. Let's move that to off. And actually, that, I bet you, is what these other two wires are. Of course it is. The other two wires are connected to the switch back here for the demo mode, without a doubt. So now let's put some batteries in. And 1, and 2, and 3. And we drop it on the floor, almost. So now I'm going to turn it to the on after making sure the lever is in its off position. And notice I have pushed it down too far. Gotta be careful, just like I said. Do as I say, not as I do. So we'll turn it on, and does not work. Let's try again. And of course, I have broken it. So the first thing you think is you damaged it, but I see nowhere that I could have damaged it. So the other thing that we think is perhaps one of the two components that I removed was connected somewhere in series. So I'm going to do something dumb. Well, first I'm going to do something smart and remove the batteries again. But what I'm going to do is those pads where I disconnected, I'm going to use solder to short across them. So that's going to do one of two things. Either that will fix it, or it will cause a damaging short circuit and fry the device, which is very little loss because apparently I've already fried it. So I will go ahead and get some water for the little tray in my soldering iron. There we are. We'll turn the iron on and let it warm up. It warms up very quickly. As you can see as I speak, it's already up to 200 degrees. That would be Fahrenheit. That is warming the tool up to 750 freedom degrees. I will get my solder. This is 6040 lead and I don't know what SN is, perhaps selenium. I am not a chemist. That's just the first thing that came to mind that has S and N. So now the soldering iron is warmed up. I have solder. Now, whether this will work depends on whether the device was relying on inherent resistance in the speaker and microphone, which is incredibly likely. Remember, we did take our batteries back out, so the only thing that has power is capacitors. So let's go ahead and apply a small amount of solder to the iron, and don't breathe the fumes. It's called tinning. And we wipe off the excess. The solder contains something called flux inside the solder, which is a caustic substance that will remove oxidation, which causes a better connection because oxidation makes it harder for the metal to stick to itself and also conducts electricity not as well. So you tin the tip to clear off some oxidation on the iron so heat conducts better. So now I'm not actually soldering anything to the board, so all I'm doing is going to melt solder and stick it on. So I don't need to actually heat the board any more than coincidentally. Wow. Whatever is on this board, I basically touched it a slight bit and it just had quite a chemical reaction, so that's encouraging. So let's try a different method. There we are. I'm having to use gravity to drop it, so I'm applying much more solder than I wanted to. I have to be careful to not short another trace. Let me switch to my dominant hand here. So I'm going to melt and draw the solder over. This is a terrible quality board. Holy crap. Cost-saving measures. And just for the record, I'm not expecting this to work. Right now, I'm mainly having fun, because if this no longer does its thing, I'm not going to be fussed. I would not have done this if it had been expensive. $20 is not no money, but it was alright. There. Normally I have my fan on, so I'm not breathing the fumes. So right now I'm just blowing them away a little bit. I would not do a full soldering session like this. So now I have created a solder bridge across those pads, and you just look and make sure, because you can see the trace on the board, the physical lines. Just make sure it's not touching anything else. So that was the speaker connection, and now the trickier one, because it's next to a wire I want to keep good. Much trickier, in fact. But let's try it. All we can do is fail. That should be enough solder. Now to try and connect the two little bulbs, and there we are. Pull it off for a moment, let it settle. Make sure it's not touching anything else, which it almost is. Let me try and remove a tiny bit of the one that's near that other wire. Now, if you touch the soldering iron to solder, it will pull some of it off if the soldering iron has no solder on it. So you can use that a little bit to wick. So I can get a little off, wipe it on there, and the wire for the switch has come off. I have accidentally desoldered the power switch. So yes, spoiler, this is not going to work. So what I will do now is just resolder this power switch in there. It's going to drop it on, drop it on in. So it's in solder now. Go ahead and turn my iron off. I won't be needing to do this Dr. Frankenstein style surgery anymore. And now let's find out what we already know, that I have broken this device. But just because I broke it doesn't mean I didn't learn. And let's try it. Oh, would you look at that? It's actually working. Ha ha! Now the real question. The real question is, will it fry or not? Because it doesn't have resistance it expects. The batteries, see, this is safer because it's battery power. The batteries can supply only a certain amount of amperage. Yes, they can supply enough to fry a circuit, but they're not going to supply enough to catch fire. This is not dangerous to me. This is possibly dangerous to the board. But the worst that's going to happen is this stops working, not my apartment catches on fire. If this was a regular power supply that could draw all the current at once, you would not do that. But with batteries, it is safe. So you can see the motor here turning. You might be able to see if I block this a little bit. The motor down here turning. And nothing has fried so far. I'd say we're good, and this actually turned out to be a success. So let's put her back together. Turn it to off. I won't bother taking out the batteries this time since I'm not going to go back to working on the electronics. It would still be a good idea to take the batteries out so you don't accidentally hit the switch, but that switch is unlikely to be accidentally hit. So I'll go ahead and reconnect the spring as carefully as I can without stretching it too terribly much. Put the screw head on. This is really the only delicate part because if I stretch the spring too much, then it won't close properly. But the solution to that could be pinch part of the spring, or even get a new shorter spring. So now I will close the lid, and it won't close entirely because the motor is partially up. So let me hold it roughly at the hinge and try and get it to settle. And now it stopped working. Oh, never mind. I had the switch off. I forget when I'm safe. So now let's let it settle. There we are. So now it's mostly closed, and we'll turn it back off. And now we just have to stick the hinge pins back in. Remember the little rough part goes on the outside. Try and line it up. That's the fun part. There we are. Let's take our flathead screwdriver and shove it in. Make sure it's going in before you do any strong shoving, of course. Get out of here, glue. You've done your job. The glue wanted to be friends. So now the other hinge, settle that down, and the screwdriver to push it the rest of the way in. And now the hinge. Looks fine, the spring is holding. And now the battery compartment cover. And there's no reason to not use the batteries that came with it until they wear out. If I was going to go ahead and hook this up for an actual Halloween display, obviously you would put in fresh batteries because you don't want them to run out in the middle. But this is not for Halloween display, this is for me. Good news? I stripped the threads of the hole the screw goes in. But that's alright. That's the kind of thing that duct tape is for. But we're good right now. Moment of truth. Reassembled? How's it look? Spooky. Ah. And there we go. There is a hot topic in this country right now. This country, the US of A. It's called right to repair. You may have heard of people like Louis Rossmann or Leonard French, big proponents of it on YouTube and the internet in general. Basically, if you own something, you should be able to work on it. The California farmers just gave up their right to work on John Deere tractors. Companies like Nintendo are forever trying to strengthen the Digital Millennium Copyright Act, DMCA, which covers more than just copyright, and is internationally applied, even though it is a US law, to try to remove our rights to even modify for our own use, not just repair, but to alter. I should be able to open up a dinky little electrical Halloween box I got at the hardware store and remove a speaker. I should be able to take out the rumble motors in my gamepad. I should be able to do whatever I want with what I own. Don't give up that right. Such a simple little thing I did here. It's so casual, you'll think nothing of it, for those of you who are even watching this far in the video. But your government, and most notably, all the companies that control it, or, if you're luckier, only influence it, don't want you to be able to do that. They would be happy if you don't even own your things anymore. But, lest this get too political, I've said what I'm going to say. In the meantime, whenever you may be watching this, happy Halloween. Be seeing you.